I'm Hassan Bashir and I will be moderating today's webinar. The moderator for today's session, Ms. Ebla, will not be available with us due to some unforeseen reasons. So I'm here to moderate the webinar organized by FACT Exhibition. FACT Exhibitions Private Limited is the leading exhibitions and conferences organizing company in Pakistan, specializing in industrial and corporate trade shows, embracing a portfolio of over 25 industrial sectors and being the UFI approved event organizing company. Its events are absolutely in accordance with international standards. FACT Exhibitions Private Limited, the organizer of Solar Pakistan, country's only dedicated solar energy exhibition and conference, have taken the initiative to organize an informative webinar series on the solar energy situation in Pakistan and worldwide to facilitate and cater needs of the industry. Currently, industry professionals are looking to know about the top trends in the solar energy industry in Pakistan and worldwide. Also, connect with experts in their respective fields. Global leaders and future strategists will open a forthcoming discussion for solar professionals to stay engaged with the industry peers and attempt to keep them a step ahead. Dear attendees, Solar Pakistan webinar number 8 is sponsored by Jinlong Solis. Solis is the first publicly traded company with a primary focus on string inverter and the first inverter manufacturer to complete PVEL, third-party inverter reliability testing. Please note that you can view the recorded webinar on FACT Exhibition's YouTube channel, fakt.tv, fact.tv. Our valued panelists for today's webinar are Mr. Tony Gao. He is the Technical Senior Manager of Jinlong Solis. The second panelist for today is Dr. Naveed Arshad. He is Director, Lungs Energy Institute. The third panelist is Ms. Carrie Yang. She is Sales Director, Zinshine Solar. And our last panelist will be Mr. Nazif Hassan. He is Deputy GM Renewable, Central Power Purchasing Authority, Government of Pakistan. Please note that we will have a question and answer session at the end. So you could leave your questions here in the Q&A section on Zoom and our panelists will answer them. Now I would request Mr. Tony to take it from.
Hello, everybody. Thank you, Mr. Bashar, and for the FACT exhibitions give us this platform to show the solar inverters. Sorry about the internet issue. So I will just start right now. So my presentation, there are two parts. The first one, I'm going to introduce the Solis company. And then next, I will talk a little bit about the commercial and industrial solutions using the Solis inverter. And in the last part, I'm going to show you some case references. Okay, so this is the timeline of the Solis. The company was built in 2005, and in 4 years from then, we have completed the complete product producing chain line for the inverters. And in 2015, we installed our Solis inverter in Eiffel Tower in Paris, and we are the first traded company with a primary focus on the string inverters. Going to the stock market in 2019, and this year 2020 we are celebrating our 15th anniversary. And here is a market map of the Solis inverter. And the Solis inverters ranked the third in Chinese exports in 2018 and 2019. We probably we are fitting the 7% of the market. And for the single phase inverter market, we are ranking the number 2 in the global scale. So we are ranking. So we are counting like 12% of those single phase market share. And also we have 40% domestic residential inverters shipments. And also we got the certifications from those institutions. We are commented by the DNVGL. They said the inverter life models presented positive, long and impressive track record of PV inverters designed and manufactured by Jinlong. the useful life projections are as the software life projections. And also, we were called the most bankable Asian inverter by Bloomberg NEF. And also, we received the awards from the EU PD research for 4 consecutive years. So to deliver the top class inverter to the customer, we only purchase the parts in the top class. So we're using, you can see from this figure that we are using the IGBT chip from the Infineon, and we use the Datalogger LCD screen, and also we use Panasonic connectors, and also we use a chip from Texas Instruments, and also we cooperate with Omron for the connectors and some other famous electronic companies. So this is our production line and the process. So we are manufacturing the inverter from the very beginning, starting at the surface mounting technology. Then we have the PCB patching process, and then it's going to the inspection phase, and then wave soldering all those electronic units on the board, and then it's going through another inspection phase, and then it's anti-corrosion paint on those the PCB boards. Then it's assembled and going through the ADP, and then we do the functional testing and durational testing before the inverters are going out of the factory. All right, so next I will going to present our commercial and industrial solutions. So here is an overview of our technologies. So the inverter got a high yield. It achieves a maximum efficiency of 98.7%. And we use this Solis 80K, 100K, and 111K series as an example. They have the inverter is compatible with bifacial solar modules, and it can support 26 amps for the MPPT inputs. And for the 80K and 100K models, they have 9 MPPT inputs, and for the 1110K, they have 10 MPPT inputs. And also, excuse me, and also the inverter is supporting a 10% more AC overload capacity. We also provide a PID recovery solution. It's a board integrated in the inverter body. And also we brought up some technologies to reduce the cost for the customer, such as we have those 2-in-1 Y connector. So you can basically save cable cost on this by using this technology. Sorry. And also we are supporting the aluminum AC cable and the PLC communication standard. It's power line communication. And also we are supporting the night VAR function. And also we do the use a fuseless design for the inverter, so there's no active fuse inside the product. Instead of the fuse, it is a breaker. And the inverter is fitting the type 2 SPD protection level for both DC side and AC side, and fitting the IP66. We have the intelligent redundant fan cooling to make sure that the inverter is working in the adaptable temperature range. And we also have the AFCI protection function. So also we do the smart operation and the maintenance by such as the smart IV curve scanning and strain level monitoring. And also the inverter is supporting the remote upgrade. So this is a topology showing that how the inverters was connected to the grid. So you can see we have this 80 to 110K model series as an example. So these are two input. It's a DC input from the PV panels, and the AC output from the inverters will be combined in the AC combiner box. Then it's going through a low voltage cabinet before it's going to the electricity is being sent to the loads, or either to the loads or to the grid. And the model is being connected in parallel. We also do the smart control of the inverter, and we have recently a solid cloud application. The app is shown in the market, so that a customer could monitor or even control their inverter remotely. So we use this. It's called a Datalogger. It's stick Datalogger, or it's one inverter will be connected to one Datalogger, and the Datalogger can send the signals or data through either the Ethernet cable, GPRS, or using the Wi-Fi router to the monitoring platform. Then the customer will monitor the inverter, use a computer. And also, in addition to the stick Datalogger, we also have a Datalogger box. So one Datalogger box will be connected to up to 10 inverters. It's still the same function as the stick Datalogger. It just collect the data from the inverters and send it to the monitoring platform through either Wi-Fi router or the GPRS. Also, as mentioned before, where the inverter is supportive to the power line communication. So this is a very advanced technology in the field right now. So we can send the data signal or control signal through the existing AC power line, so that the customer can save the money on building, extra infrastructures only for the communication. So all those signals carried by the power line will be sent to the so-called SOLIS PLC CCO, is a communication center, and the signal will be decoded there and sent through an RS-485 to the monitoring box. And then after that, it's the same. It will be a transfer. The data will be sent to the monitoring platform. So this slide shows the technology of the two-in-one white connector. So you can see in the bottom left corner, here we have two strings of the solar panels, but connected with one cable into the inverter. So basically, the customer can save like half of the cost on the cables, comparing to one string, one cable configuration. So you see the overall DC wiring cost could be reduced around 20%. Also, we can use the AC aluminum cable instead of the copper cable. Also, for the purpose of the saving the cost. So you can see here the data shows that for the same size of the current carrying capacity, the aluminum wire is like 3/4 of the copper wire, but the cost will be much lower than the copper wire. So there will be an overall AC wiring cost reduction around 50%. So this slide shows the EPM. EPM stands for the export. It's export control device, and it will be installed between the grid and the inverter, so that it can prevent any some grid is requiring they have different requirements on the power output from the inverter, so that the EPM could monitor that, and to monitor the case that how the inverter is sending the AC current to the grid. So this is a PID recovery function. So the PID stands for the potential induced degradation. It's a bad impact which happen in all those solar panel frames. That during the usage of the solar, they have a positive voltage between the frame, and then it will degrade the performance of the solar panels. So basically, we will use this internal PID board to add a reverse voltage to those frames, so that to cancel out those floating PV voltage to prevent that degradation of the solar panel. So this slide shows the AFCI function. So the arc, it's a dangerous point in the solar station, either the DC arc or the AC arc. So we have built this arc fault circuit interrupter into the device, so that when the FCI detect the DC arc fault, it will be in time to stop the whole inverter and to cut off the inverter from the grid before a fire is coming out. And also the FCI function is fitting the UL 1699B standard. So this is our solid cloud monitoring platform. We can do a lot of monitoring functions through this platform, such as you can see your EPM data through the station, and you can see the like power generation by day, the month, or year, and you can build your own power station database in the platform. And also the platform is supporting the remote control function. It can monitor into the string level of the solar panels, and also supportive to the IV curve scanning. So the final part, I'm going to show some cases, just simply. So this is a commercial industrial use of the for a plastic factory. It's 564 kilowatts. And this is like 1.1 megawatts project for construction engineering company. A 2 megawatt for the molding company. Like about 965 kilowatt for a packaging company. This is a little bit more than 2 megawatts for Pioneer, I think it's engineering park. This is a chemical factory in Vietnam. It's 200 kilowatt. Also a packaging factory in Vietnam is 924 kilowatt. This is another project in Vietnam. It's 430 kilowatt. This is a project in Netherlands. It's 2 megawatt. So that will be all. Thank you.
Thank you, Mr. Tony, for an informative session. We would request you to please stay with us. So if you have any questions at the end of the session, you may answer.
Okay.
Now we would like to invite Dr. Naveed Arshad, who is Director, LUMS Energy Institute. Sir, you have the floor.
Thank you very much for giving me an opportunity to talk to the community of involving in solar energy in Pakistan. So my talk will be slightly different than the talks probably in the rest of the panel. So I'll be talking more about that. Well, Pakistan has a ambitious renewable energy plan. We are also facing a capacity trap in terms that we have producing too much electricity, or we have too much energy that is at our disposal. So how can we actually make sure that we make the best out of it? So my name is Naveed Arshad. I am a associate professor at the SSC LUMS, and I'm also the CEO of a new company in electric vehicles, and that's called Renewable Energy Services. I would like to thank colleagues and students who have helped me prepare this work all throughout these years. So when we look at the news, we see that Pakistan has an ambitious plan for renewable energy. So government just announced an ARE policy, alternate renewable energy policy, where the target is set that by 2030 we are going to have 30% renewable, and this does not include hydro, because hydro is considered as separate from renewable energy at this time from a technical or from a legislative definition perspective. And if we add hydro also, so we are looking at 60% renewable energy in Pakistan by 2030. This is by far an ambitious target, because currently we are probably less than 10% of a renewable energy target, and this requires a lot of renewable energy addition into the system. Now, on the other hand, we also have another problem that we have in capacity surplus. We have about 4,000 megawatt of extra capacity in our system, and I'll go into that where do we have that capacity. And together, this problem actually leads us to a problem that we have been seeing for the past many years, and that's the circular debt problem. Currently, we are at about 2.3 trillion rupees of circular debt in the power sector, and the other 800 billion is in the petroleum sector, and that circular debt is certainly not sustainable. It's an economic nosedive which we're into. Every day, we are actually accumulating more than 1.5 to 2 billion circular debt every day. By the time you'll end the seminar, probably we'll be accumulating millions of dollars of circular debt. So before I go into the rest of my presentation, let's look at how the power sector works. The power sector has a certain way of operating. Since we do not have massive scale storages, so we need to have a matching kind of criteria from supply and demand. So this, let me have my pointer here so that I can point to stuff. Just give me a second. So this is the bold line over here is the load curve for a particular day, and which we typically fill with must-run plants such as nuclear and renewables such as hydro and solar and wind. And then on top of that, we then kick in the fossil fuel generation. And depending on how much demand is, the fossil fuel generation is added into the system. So there's a merit order which we follow, and then different plants are then added into the system so that we maintain a demand-supply balance. Now, the problem is that these fossil fuel generation in Pakistan are on a take or pay basis, which means that this whole box, we have to pay for it whether we like it or not, which we call the capacity payment. And that capacity payment is something that we have signed up for the next 25, 30, whatever the duration of that contract is. And whether we like it or not, we have to pay it. In fact, we have bought that capacity for the next 25, 30 years. Now, this gray part, which is remaining, is something where we are paying for the capacity payment, we are not getting it back because we have not bought that energy. We have not used that energy. We have not got any payback from that energy. So this is what we call the unrecovered fixed cost. So in Pakistan, over the years, what has happened is that we have installed our capacity based on the base plants. So the planning was for the base plants, but we have installed the base plant even for the peaks, which means those plants are available to us all the time, but the peaks are occurring at a very short duration during the days and during months. Just give me 2 minutes time when my time is over, so that I do not overrun my time. So this is a study that we carried out at LUMS Energy Institute, and it is verified by other entities in the power sector that we are going into a capacity surplus. So this is an interesting graph because there are 4 or 5 different lines that you'll see. And the red line that you see is the demand that we have. This is the monthly demand, monthly peak demand. The green one is the monthly base load. So let's say in the month of November where we are, what is the maximum peak that we'll take in November, or what is the base load that, so minimum demand that we have in November. So this red line and the green line are the peak and the base load respectively. The blue line is the capacity that we have in fact, the yellow line is the capacity that we have in surplus. And the blue line is the available capacity that we have in surplus, because some plants may go in maintenance. Sometimes we don't have water in Terbela during winter. So what's available capacity? If you look at it, our total demand, the maximum demand, we are going above that. So for us, we have more availability even than our highest demand for the next 60, 70 months. That is from now until 2025. And the dotted line that you see is the forced load shedding that we do, not because we don't have electricity, but there are a couple of reasons. One is that we do not get paid back the bills, or so recovery is low, or in the summertime, sometime the system constraints kick in. So even if we consider the dotted line, the blue line and dotted line are quite different. So we have excess capacity, and these bar charts in the middle of this screen will tell you that how much extra megawatt that we have on top of our maximum capacity, maximum load. So 10%, 11%, 11%. So in the next 5 years, 6 years, we have on average maybe 15% extra energy that we have, more than our top load. But this is not the whole story, because this is just telling us the peak demand and then energy that we have on top of peak demand. There is variation in the day and night, variation amongst the months, variation in seasons. So in terms of capacity, our total capacity is much more than our need. So for example, the red one is the total capacity that our need is on a yearly basis. So 150,000 gigawatt hour is our capacity that's needed in 2019. In 2020, it will grow to 152, and then so on. By 2025, we will have a capacity that will be near about 200 gigawatt hour. But we have 50% extra capacity in our system if we consider throughout the year. This is the gap that we have last year, and again the gap is widening. And this is taken into account all the projects that are in the pipeline, that are signed, that have financial close, that are in construction phase. We can delay it by some negotiation, but there's not much room that we have in terms of improvement. So we have a lot of capacity in the system, and all this gap, the red and between the blue and the red, is what causes our rates to go up, is what causes one of the major reasons of the circular debt in future will be this. There are about 12 or 13 reasons of circular debt, but this is one of the major reasons that will be in the next few years. So this is the excess capacity, excess energy in one graph, that if we look at in terms of percentages, how much excess capacity and excess energy that we have. So in terms of capacity, we are way over. In terms of energy, we are also way over, because we are not going to use all that energy in our system. On the other side, on terms of load, we also are facing an issue. So this is the load for Pakistan, except K-Electric, that has been dispatched between 2016 and 2020. If you look at it, this part is the winter load, and the peaks are actually the summer load. And these peaks represent the summertime load. So when the summer season comes up, so this one is actually kicks in. But you see there is a problem here. Our winter months, our load is pretty low. So this bottom one is about 8,000 megawatt, and this maximum load in winter is about 12,000, maybe 12,500. For the last 4 years, our base load from winter season is constant. No load growth. This is not possible because there are new housing colonies built all the time. There is new, you can say, commercial activities that are happening. So why the load is going down? In fact, it is going down because we are adding new sources, adding new loads, but from the system dispatch perspective, the load is constant. So it means there is something negative going on. There are reasons for it: negative industrial productivity, there's the influx of solar, there are others, captive generation. But the point of the matter is that our base load is very, very low. In fact, this is so low that we need to do something to actually increase it. Otherwise, the system is not sustainable. Now, in the last few minutes, what I'm going to see that we are in a conundrum. And conundrum is that we have big aspirations for renewable, but we have excess capacity as well. And that excess capacity, somehow we already have contracted for the next 20, 25 years. We are paying for it. We can do some financial engineering to reduce the impact, but what happens to our renewable energy aspirations? So this is the crux of the talk, which I'm going to talk about next. Let me see. So one thing is that why we have now more capacity and less load is because we were lacking in planning, in generation planning, load forecasting, generation planning. For the last 15 years, there was no planning that was happening. The first plan that came out was last year after a delay of about 15 years. So without any planning, the government and the provincial governments and other entities were signing projects left and right. And that's why we are now in a capacity trap. So planning is given priority so that we don't go into the mess that we have already into. Second thing is we have to increase our base load. There is no other choice that we can use this capacity other than increasing our base load. Introduce electric vehicle to convert the whole transportation fleet to electric vehicles. This will save our import bill. It will save the environment, but it will also use the capacity. Our natural gas is going serious limitation on natural gas reserves. Natural gas shortages are already, you are seeing maybe in your houses that natural gas is in short supply. We have to convert these natural gas, you can say, loads to electricity. So domestic cooking, geysers, other things, we have to convert it to electricity. And wherever we have base load plants, in order to reduce the losses and everything, maybe we can establish the special economic zones near those plants so that there is economic activity wherever the electricity is available. And then rationalize electricity prices. This is something that government has already done. And they have introduced new prices for industry for the next 6 months, or maybe for the next 6 months to 3 years, where they can use lower energy prices for use in whatever they're using now. If they use more energy, they have to pay less. We should have a moratorium on fossil fuel plants, except any strategic ones. And strategic ones means third coal, which somehow we need in order to have local supplies of fuel. But other than that, there should be no imported fuel. I mean, this decision was taken back in 2016, but still there were violations of that, and many plants were established because of that violation. One thing that has really caused our problem is a sovereign guarantee of the government to energy generation projects. So the government is giving a sovereign guarantee. The government of Pakistan will buy all the energy that these plants are going to be producing. Basically, we are guaranteeing, so the government is guaranteeing the investors, so-called investors, because with sovereign guarantee, I don't know what investor mean. They are now, I mean, they're hostaging us or putting our money or our next generations hostage for signing up these 25-year agreements. And generally, the people who are signing these agreements are already at the retirement phase. So by the time these agreements will impact us, they are already gone from the world. Electricity market is coming into Pakistan. It will be starting in about 18 months. So CTBCM is the electricity market framework that we are developing in Pakistan. This should start with the renewable energy generation. So rather than allowing any new plant, a fossil fuel plant, it should start with solar renewable energy generation so that we start from electricity market from day one with new solar plants. So that's something that we should be thinking about. Then we have a lot of other opportunities of solar PV penetration. So for example, floating solar PV, using our dams as a real estate and using the existing transmission and distribution network to use the plant. We have done some studies. You can browse it on the internet. And then off-grid solar. A lot of Pakistan is actually off-grid. Solar energy is probably the best, you can say, energy source for them. Agri-photovoltaics. We are facing climate changes. We are facing impact of very hostile climate, very cold and very hot on our crops. Maybe agri-photovoltaics can help us and also reduce energy. Rooftop solar, of course, net metering is there, but I think that government will curtail it, net metering in its current form. But I think we should not be doing it, because although it will have a short term, it looks that we are saving energy, but in long term it's going to create problem. And then finally, there's not a lot of work happening in terms of batteries, and I'm talking about the grid scale batteries, which are really taking the world by storm. And in order to solve the intermittency, variability issues of the solar or other renewable energy sources, I think battery is something that we really have to look at. And finally, we have the integrated energy solutions that we should be looking at. So solar, hydro, wind, and battery, and other combinations. Then we should be looking at solar heating and cooling loads. The peaks that I showed you in summers actually are coming from the cooling loads. Somehow, if we can convert to solar, that we'll be able to save our peaks. And the peaking plants are typically the most expensive plants and the most expensive for the power sector. And finally, something that we should be looking at is a 100% renewable energy plan for Pakistan, where we should be generating our 100% renewable energy from renewable electricity from renewable sources. We have been working on one plan for 100% at 2050, and we have seen that it is possible. Of course, there are a lot of technical challenges, but the world is following. The technical challenges will be solved from now until 2050, because it's 30 years in between. So these are some of the steps in which we can actually take care of our capacity, excess capacity, and also of our renewable energy ambitions, because somehow both cannot go hand in hand. We somehow have to reduce capacity somewhere to have way for renewable energy. So this is it. Thank you very much from my side, and I'll be happy to take questions. Thank you very much.
Thank you, Dr. Naveed Saab. We will inshallah have the Q&A session at the end of the presentation. And thank you for such an amazing session. Moving forward, I would like to invite our third speaker for today, Ms. Carrie Yang. She is Sales Director at Zinsign Solar. Miss, you have the floor.
Okay, thank you. Dear ladies and gentlemen, I'm glad to be here to attend this webinar to share my topic with all of you. So I'd like to share you something about Zinsign Solar and its products. So my presentation will divide it into 4 parts. So for the first section is who we are. The second section is our new technology for graphic coating modules and double glass modules. And third part is for the main products in next year. And last, the section is how to contact with us. Okay, so let's come to part 1, who we are. So for Zinsign Solar was founded in 1988. So until now, we have a history of more than 32 years, and we are Tier 1 module manufacturer in China. And our headquarters is in Jiangsu Province, Changzhou City, and GC Town. And Zinsign Solar is the biggest PV company listed on NEEQ. As you know, we have so many years experience for manufacturing, so we have got the top performer from DNVGL, the most famous third-party certification agent. At the same time, we are very reliable, and we have the good bankability for all modules, and which can help our EPC partners to get the loan from the bank very easily. And here is the milestones for Zinsign Solar. So we established in 1988, and we just entered solar business in 2007. In 2008, we just realized globalization, and we set branches all over the world, such as in Europe, in Australia, in Brazil, and in India, and in some other markets. And in 2013, we become the Tier 1 solar module supplier in Bloomberg. In 2014, we just get the EPC qualification in Japan market. Zinsign Solar is the first company who has the qualification, and even some Chinese company, if they want to do EPC business in Japan market, they need to use our qualification. And in 2016, we just listed on NEEQ. NEEQ is just like New York Exchange in China, in USA. And in 2018, we become the top 1 module supplier in India. And in 2019, our capacity could reach the 6 gigawatt. But in next year, our capacity could reach the 10 gigawatt and 6 gigawatt in GC factory and 4 gigawatt in Suqian factory. And here's some partners we have been cooperating all over the world, such as in China, Huawei Inverter, and Power China, and CGGC, and Energy China. We have good partnership with the state company. And in Europe, we have good partnership with EDF and Low Carbon and ABC Solar. And in Middle East, and we have good. We also have good partnership with some customer, such as in India and some other markets. And actually, our business could be divided into 3 aspects. And the first one is EPC, and we have 1.1 gigawatt project construction all over the world. And the second, our business is for the module manufacturing. And just as I mentioned, next year our capability will reach the 10 gigawatt. And the last one is about the solar solutions. Except for modules, we also offer some solution to the market, such as we could give you some suggestion about the whole solar systems, including the inverter and the mounting systems. Because we are in China, we have good resources for the whole systems. And the last one is for our mission. Our mission is to make the solar energy become the most economic clean energy in the world. Our vision is where there is sunshine, there is sunshine. Our value is to be fairness and trust. And here let's come to our part 2, our technology for graphic coating and double glass modules. And first is our graphic coating. Graphic coating. Graphene material is known as the king of new materials. It is the world's thinnest, lightest, and most flexible, strongest, and most conductive nano materials. So the purpose why we use the graphic coating modules, the use of graphic coating modules is try to increase the output of the modules. Now let's come to the key feature of graphic coating modules. The first key feature is self-cleaning, and the second one is anti-dust, and the third is high reliability. And the most important is that with the use of graphene, we can just add 2% of power compared with the standard modules. Now let's come. Let me share you some pictures about the modules with graphene and without graphene. You could say that for the normal modules, modules means without graphene. The picture before running and after running, and the surface with the module is very dirty. And this is the pictures with graphene. You could say, no matter it's before running or after running, the surface of the module is clean than the normal modules without graphene. It is because the physical characteristics of the graphene. And this, in order to promote our graphic coating modules, our engineers, and we just make serious tests to prove that our graphic coating modules is very reliable. We just make the test just like you can say the double 85 and UV radiation and sand resistance test. After serious test, we prove that graphic coating modules is very reliable because its light transmittance and pencil hardness, hydrophilic angel, and organic decomposition is very good. We not only do the test by ourselves, actually we also send our modules to the third part to inspect how our graphic coating modules works. And here is the test result we got from the PV magazine modules, PV magazine test result about the banker test. And it showed that the graphic coating modules energy yield is better than other brands' modules. And here is the data. We just do serious test. We just make some projects in operation and we test the result. We found that you could say that the dust influence, the modules with graphic is about 2.85%, but without graphic, and the dust influence is 8.52%. And at the same time, it's very important for the end customer because they want to get more output from the modules. So for the power generation, we can get the result that with the graphic and 2% higher than the normal modules without graphic. Double glass is another new product we are promoting in the international market. So why we just promoting double glass modules in the products? Because the following advantages. The first is compared with a single glass, double glass is more lighter and higher reliability. And the second one, for single glass, as we know, its linear warranty is about 25 years. But for double glass, the linear warranty is 30 years. As the third one is low macro crack risk. You know that macro crack will affect the output of the modules. So for double glass, it can decrease the possibility for macro cracks. For Zinshan solar, our modules, our double glass modules is with frame. So with frames, what benefit? It will be easy to transportation and it will be also easy to installation. It's very, it's very interesting that the structure of the double glass is the cells, EVA, then glass, just like hamburgers. Yes, it's very interesting. For double glass modules, until now, we have shipped more than 30 megawatt to the international market, and most of the modules just shipped to Middle East and South America. But actually for Pakistan, we also have some customer has been accept the double glass modules, especially in Islamabad. And we have some customers who has been buy our double glass modules and used for agriculture projects in Pakistan. And we just get good feedback from the customer. They are very satisfied with the output of the modules. No matter for the graphic coating modules and the double glass modules, and we believe that Zinshan will be there, no matter how the market just changed. And we are trying to offer the most advanced technology to the solar market to do something for the new energy in the international market. And here's some reference of the Zinshan solar all over the world. And now let's come to our part 3, main products in next year. So actually big site cells and modules, new cells technology and a new module technology. You know that maybe in 2015, maybe the main product is 340 watt panels. But in this year, 400 to 500 watt panels is very popular in the international market, especially in Pakistan market. all the module supplier just promote their 440, 445, and in next and in Q1 next year, maybe 500 certified panels will be the main products in Pakistan and in all over the market. And for the Asian solar in 2021, and we will promoting our 600 watt panels, and it will be start production in Q3, and before Q3 our main products will be the following products. For next year, our main products will be based on 182 lamination cells, and the watt can and the watt will reach the 520 and 540, and the efficiency will reach the 20.34 and 21.13. And the second one is based on 210 examination of the cells, and the power will reach the 585 and 605. These are the new products for the Asian solar. But based on the market situation, we will also produce the for poly 330 and 330 watt, because you know, maybe in Pakistan, poly is not very popular, but in other market in Australia, in some roof projects or ground up projects, they are need poly. So poly we will still produce for poly, but we will also produce the mono, and 530 and 535 will be the main products for the Asian solar in Q1, Q3 for Q1, Q2 next year, and Q3 600 watt panels will be our main products. And here is our company's name. In Chinese is Zhengxin. Zheng in English means fairness, and Xin means trust. So we want to the right thing, and we want to be reliable for all our partners. And this is the last part. So if you have any question for the Asian solar for our products in Pakistan, you can contact with us. You can send email to me. You can add WhatsApp and WeChat for me. And we hope we have seen the big potential for Pakistan market, and we believe that with the two government support and one belt, one road, we believe that Pakistan will change its energy structure soon. And the Asian solar, as a module supplier, we would like to do something for Pakistan to help Pakistan to change the energy structure and to achieve the energy target as soon as possible. So I'm glad to be here. Thanks for listening and sharing. And I have to just finish my speeching because time is limited for me. Okay, thank you all.
Thank you, Ms. Kelly. Moving on to our last panelist for today, I would like to invite Mr. Nazif Hassan, who is Deputy General Manager Renewable at Central Power Purchasing Authority, Government of Pakistan. Sir, you have the floor.
As you have already introduced me, I am representing CPPA, and today my topic of presentation is solar energy industry development in Pakistan. Okay. First, I introduce the energy or the role in development of the modern economics. A country cannot succeed without proper utilization of energy. It is considered the main component of a country's economy, Pakistan being a developing country. And due to recent development and to support its large population and industry, the country needs a huge amount of energy to keep all things on track. The gap in electricity demand and supply has been increased in the past few years and is highly obvious during summer season, which has resulted in the complete shutdown of power for 4 to 6 hours in urban areas and for 16 to 18 hours in the rural areas. Energy generation is heavily dependent on fossil fuels. Crude oil, coal, and gas resources in Pakistan. Due to the huge population and current progress in industrialization, the country fulfills its energy needs by utilizing fossil fuels. Meanwhile, they have adverse environmental impacts and are economically unsuitable to electrify remote areas. Huge dependency on fossil fuel not only has a burden on the national economy, but also have led to different environmental hazards like the greenhouse effect, CO2 emissions, global warming, and irregular weather patterns. Consequently, there is a need to look for alternate energy resources. In recent scenario, solar power development is the best renewable energy option for Pakistan in terms of price, lifespan, operation, and maintenance cost. Moreover, natural resources are being exhausted due to overuse of fossil fuels. Hence, there is a need to develop a new energy economy. In this new economy, renewable energy sources, especially solar power, can be utilized to produce energy which can decrease the fossil import bill on one hand and lessen the climatic changes on the other hand. Energy demand is increasing in Pakistan by more than 9% annually in Pakistan. It is expected that energy demand will increase 8-fold by 2030 and 20-fold by 2050 in Pakistan. The major reason of energy crisis in Pakistan is that energy structure is mainly dependent on natural gas, which are expensive as well as are under huge pressure of shortage. In the recent past, the share of hydroelectricity has reduced significantly. Moreover, renewable energy resources only fulfill 8% of the energy needs of the country, which is almost negligible. Among different renewable energy options, solar energy has the potential to tackle all these challenges. It has emerged as the most competitively priced technology worldwide. According to the International Energy Agency, global capacity of solar PV has reached 452 gigawatts at the end of 2020. It will further expand by almost 550 gigawatts in future and lead the renewable energy capacity growth. Geographically, Pakistan lies in the sun belt and receives massive amounts of sunlight all through the year. To address the current energy crisis, it is very important to exploit the existing energy resources. Meanwhile, public and private sector investment is very important to harness its true potential. Many researchers have focused on solar energy to estimate its potential for proper utilization of the solar resources, as the country has an overall solar power potential of 1600 gigawatt. According to ARE Policy 2019, Pakistan plans to increase the share of renewable energy technologies in the overall energy mix up to 9700 megawatts by the end of 2030. The country can achieve these targets and tackle energy crisis if it utilizes solar energy resources in a proper and efficient way. In the past, the use of solar PV was only limited to individual purposes and there was no utilization of solar energy in the grid. With a growing electricity demand gap and continuous power shutdowns, government has made quick action plans to connect solar energy with the national grid. In 2010, the first solar grid plant was installed at the Planning Commission and Pakistan Engineering Council buildings. The plant, which has total capacity of 178 kilowatt, which not only fulfill its own needs, but also can sell surplus electricity to the Islamabad Electric Supply Company. Similarly, Pakistan National Assembly installed a 2 megawatt PV solar system on its building and became the first world's parliament which is completely functional on solar energy. With the technical assistance of the Japan International Cooperation Agency, JICA, the country built another solar energy project with a total generating capacity of 365 kilowatt. Investors had taken great interest in solar energy projects after the success of the above mentioned projects. AEDP is pursuing 22 solar PV power projects of cumulative capacity of approximately 890.80 megawatt. 6 number of solar power projects having cumulative capacity of 430 megawatts are already operational and providing neat and clean energy in the national grid. 4 further IPPs with a cumulative capacity of 41.80 megawatt have obtained letter of support from AEDP and are in the process of achieving financial closing of their projects. 12 solar PV power projects of 419 megawatts cumulative capacity have obtained LOI from AEDP and are at the different stages of project development. As per the Cabinet Committee on Energy decisions, these 12 projects are required to participate in the upcoming competitive bidding to be carried out by a Alternative Energy Development Board. ADP has started a solar power electricity program to electrify rural areas. According to this program, solar systems will be installed in 100 villages of Sindh province and 400 villages of Balochistan province. Villagers took great interest in this program, and 3,000 solar home solutions have been installed in Sindh province. NEPRA has already declared a net metering policy and tariff regulations in 2015 to benefit consumers who use solar PV. A special meter has been provided to consumers which have the capability to record both in and outflow of electricity. And according to this policy, users will be charged for their net electricity consumption. Under net metering system, domestic and commercial users have been inspired to install their own solar system after the implementation of this policy. It is expected that this policy will improve the energy crisis in the country. Many NGOs are installing many solar energy projects at different locations in Pakistan, as shown in table 7 as below. First one is Asia Petroleum, 30 megawatt capacity, Chakwal, Punjab. Second one, First Solar Limited, 2 megawatt, Sindh province. Third, X Solar Limited, 50 megawatt, Nooriabad, Sindh. Similarly, Jafri Associate, 50 megawatt, Nooriabad, Sindh. Solar Blue Limited, 50 megawatts, Punjab province. Adamji Power, 10 megawatts, Thatta, Sindh. ET Solar Limited, 25 megawatt, Attak, Punjab. ET Solar Limited, 50 megawatts, Sialkot, Punjab. Crystal Energy, 2 megawatts, Thatta, Sindh. For Shine, 50 megawatt, Thatta, Sindh. Solar thermal technology is still not fully explored in Pakistan. Solar cookers, solar water heaters, solar water pumps are potential applications on the solar thermal side. ADB lifted a tax duty on importing different solar projects to develop solar power industry in Pakistan, as a result of which imports were increasingly steady. Solar pumps and solar water heaters were manufactured locally after 2013 and gained popularity all over the country, especially in northern areas. In the cold winter season, these mountain areas and electricity supply were limited. Although there is a huge potential for solar energy in Pakistan, but there are certain barriers which must be overcome to utilize this technology efficiently and effectively. One of the important barriers is the high initial cost, as solar energy projects require a long time to materialize their monetary benefits. More specifically, these barriers are summarized as follows. Economical barriers, unawareness about market potential. Initial costs are too high to start a new solar energy project. Limited government subsidies, banks are not willing to give loans for bigger projects. There are always risks associated with solar energy projects regarding their performance. Technical barriers, unreliable local technology, local production is limited and there is no production facility for solar cells at the national level. This is one of the main barriers. Dependence on foreign technology for key parts and equipment. Unauthentic solar maps to check the solar radiation intensity, and dependence on foreign personnel to install and operate large solar energy projects. So there is a need to educate the masses about the harms and disadvantages associated with traditional sources of energy. This can be achieved by launching environmental awareness campaigns to highlight the importance of energy conservation and reducing greenhouse gas emissions. All stakeholders, government and NGOs should work in an integrated and coherent way to further increase the demand of solar energy in the country. Policy structure should be reformed by giving more priority to renewable energy resources instead of conventional energy, which in fact is already has been accommodated. Management and marketing skills should be increased to explore new market suppliers and modern solar technology. There is a need to cultivate local professionals from countries expert in solar energy technology. There is a need to lessen the burden on fossil fuels by increasing the share of solar energy in the total energy mix of the country. This can be achieved by adopting feed-in tariffs and renewable energy portfolio standards. These incentives will motivate power producers to invest more in solar energy projects. Regional and international cooperation should be enhanced to transfer technology, knowledge management mechanisms, train local manpower, improve the manufacturing of key parts, and to learn from each other experiences. Then I come to feed-in tariffs. From 22nd January expressed in Pak rupees. Capacity, this is based on capacity as well as the region and the rumination for the years. Less than for 20 megawatts plants, rumination is 19.2, which reduces to 8.6 from 11 to 25 years. Similarly, between 20 to 50 megawatts, 19, and which reduces to 8.5 for the remaining 11 to 25 years. And 50 megawatts to 100 megawatts, 18.8 to 8.55. Conclusion, solar energy has emerged as a best source of new energy to tackle all the energy challenges, as it is cheaper, does not require operation or maintenance cost, and have a great average lifespan than other renewable energy. Solar energy can lessen the pressure on the national budget, which is being used for importing expensive fossil fuel, especially oil. Thanks.
Thank you so much, Nazif Saab. I hope it was quite informative for our audience. Moving on to the Q&A session, we had many interesting questions asked by the attendees, which have been already answered in the chat by our panelists. That brings us to conclude the session. I would like to thank our valued sponsor, Jinlong Solis, speakers and attendees for sparing their precious time for Solar Pakistan webinar number 8. And I would like to request you all to subscribe Fact Exhibition's YouTube channel, fact.tv, to view this recorded webinar, more videos and information. Thank you, everyone.